All right, ladies and gentlemen, welcome back to Lesson 8 in Psychology. This lesson we're going to be talking about sensation and perception. This is really the way that we bring in information through our senses and try to make some sense of it in terms of what it means and what we do with that information. So this is really a huge part about being human. It's the ability to sense things and then make sense of them, if you want to think of it that way. So that's going to be our lesson this week, and talking about sensation and perception. Before we do, though, as always, we're going to do a spotlight. This week we're going to talk about something called color blindness, and certainly from a sensory standpoint, sight is pretty critical, and a lot of people, probably some of you out there, actually suffer from something called color blindness. And color blindness is defined as the inability or decreased ability to perceive colors. Now, most people assume color blindness means you see everything in black and white, but that's a very rare disorder. Most people have some sort of color blindness that is either red-green color blindness or blue-yellow color blindness. To explain that, I'll kind of use the picture that I've got here. And if you don't have color blindness and you can see everything and perceive different colors, you should see kind of a speckled background with that's green with a red 8 in the middle of it. If you have red-green color blindness, you're not going to be able to differentiate that 8. It's going to all look the same to you. And something similar would be with the colors blue and yellow. Red and green tends to be more common than the blue and yellow color blindness. So what is color blindness? Well, color blindness is a problem with the color sensing cells in the eye, and those are called cones. We have things called rods and cones, which essentially deconstruct colors for us based on our sensory input, and we'll talk about that in a little bit. But people with color blindness have a problem with that color sensing cells. As I said, some people can see no colors at all, but it's fairly rare, and color blindness tends to be a hereditary trait, and it's something that impacts mostly men. About 1 in 10 men are impacted in the world, and very, very few women. So this tends to be an issue that guys deal with a lot more than ladies do. So before we get really rolling into this chapter, we've got a lot of terms that you're going to need to know. You'll probably see these in a quiz somewhere, and these are really critical because it's one of those things where we can say and use the wrong one if we don't know exactly what each one means. So let's walk our way through this. A stimulus. A stimulus is something in the environment that we as an organism respond to. Now, we happen to be an organism called a human, but other organisms respond to it too. So plants respond to light, things of that sort. So it does not have to be something that is just a human impact to be a stimulus, but it's something we're responding to. So if we see a bright light and we cover our eyes, that's a stimulus. If we walk outside in a very, very cold day and we shiver, that's a stimulus. The sensation is what happens when the stimulus has activated a sense organ. So when we sense something from our environment, we have had a sensation. So the examples that I just used about walking out, the stimulus would be the cold. The sensation is that we feel cold. We start to shiver. So it's kind of a cause and effect type thing. All right, so that's stimulus and sensation. Perception. Perception is a mental process. Perception is our brain doing some work for us. And that's where we're organizing the input that we are bringing into our bodies through our senses into some sort of meaningful experience. We're trying to understand it. What's going on? Well, I walked outside and it's Alaska in December and I'm shivering. Why would that be? Well, I happen to know a little bit about what's going on in Alaska in December. It tends to be cold, so that makes sense to me. If I walked outside in July in Las Vegas and I was cold, my brain would have a hard time understanding that. What's going on? Something must be wrong because that's not a normal stimulation. And all of this wrapped up into a psychological study is called psychophysics. Psychophysics is not what happens in your physics class with your crazy teacher, but rather it's the study of how a stimulus impacts a sensory experience. So all of this stuff, and when we study it as a scientist within the overall study of psychology, we call it psychophysics. Sensory thresholds. Well, before we can have any kind of a sensory experience, we have to be able to feel it. We have to feel it, we have to be able to taste it, we have to be able to see it. And for those, we have something called thresholds. An absolute threshold is the weakest amount of a stimuli, some sort of an outside impact, that will produce a sensation. And I've got a picture over here on the right-hand side of a dog whistle, and I don't know if any of you ever had experience with a dog whistle, but a dog whistle is a whistle that when you blow it, you can't hear it as a human being, but your dog will perk his or her ears right up because they can hear it, which tends to suggest that there are different levels of thresholds in the ears and the hearing of dogs versus humans, and that's absolutely true. The same thing would be of sight. There's all kinds of stuff going on through the electromagnetic spectrum that is outside the range of visual light that we as human beings can't understand, can't even see. But it's out there. It doesn't mean it's not there. It just means that our threshold is such that we don't have a stimuli. Okay, so that's the absolute threshold. Difference threshold would be the minimum amount of a difference that people can detect between two stimuli. So if you have a stimuli that is like a sound, let's say you have one particular note and then you drop down one note on the piano, we can differentiate between those two sounds. But if you were to parse up those sounds into 100 between there, going from one to the next might be so minor that you couldn't tell the difference between pitch. So that would be the difference threshold. And then Weber's law, a psychologist named Weber, came up with this law that says the larger the stimulus, the larger the change required to detect a difference. So if you are carrying something very, very heavy, Mr. Weber would say, let's say you're carrying 100-pound something, a brick or something that you're moving around, and you put a piece of paper on top of that, you're probably not going to notice it. But if you're carrying a feather around and you put a piece of paper on top of that, you might notice that because the difference is going to be much greater. So that's Weber's law. All right, before we can have any kind of sensations and perceptions based on those sensations, we have to have the ability to detect the stimuli. And we do that through our senses. And we then generally talk about the 5 major senses. If somebody is really intuitive, we say, ooh, they've got 6th sense or something like that. But we use our 5 physical senses, and we're going to start off by going through each one of those and talk about vision. Because we are generally, as human beings, most impacted by the vision. Vision is our most critical sense. We rely on it for more than anything else. And when we don't have it, we truly are a mess. There's no question about it. And it's tough. Folks that are fully blind or legally blind have a really hard time in our society. Doesn't mean they can't contribute and do wonderful things. Of course they do. But it makes it very difficult because we rely on vision so much as human beings. So what happens in vision? Well, light comes through and enters what's called the pupil. It reaches the lens, and these are all parts of the eyeball, and is focused on the retina. And the retina is where we have these things called rods and cones. And these are cells that are responsible for changing the light that's coming through into impulses, neurological impulses, nerve impulses that the brain can deal with. So it's essentially kind of translating what's coming through your eyes in terms of light into something that your brain can understand. Those impulses travel over something called the optic nerve into your brain, and then the brain can decode that data based on its past experiences. So when you go to a zoo and you see a giraffe, you can say, oh, okay, that's a giraffe. I know what that is. I can understand that. I've seen that in the pictures, or I've been to another zoo where there was one of those things. If you've never had an experience, you would look at that and say, I don't know what that is. That's not something within the kind of the encyclopedia that's in my brain. So the brain is decoding and making some decisions based on those past experiences in the brain. Another sense that is critical, obviously, is hearing. Hearing is based on sound waves. Sound waves are entering our ear all the time and reaching the inner ear in an organ called the cochlea. And inside the cochlea, there's little tiny hairs that move back and forth, and they're what's receptive. So where we had the rod and cone with vision, we have these little tiny hairs within the cochlea that are moving back and forth, and that is producing this nerve impulse that is then sent to the brain, and we can understand. So if you hear a police siren at a certain wavelength, you can understand that as a police siren. Oh, okay, I better pull my car over because we got a police right behind me. And that is something, again, that's a brain making a decision, a perception based on a sensation. There's a couple different things in hearing. There's loudness and pitch. Loudness, obviously, is the intensity of the sound, and it's measured in something called decibels. Just to give you an example, about 40 decibels would be the loudness of a classroom, or maybe 30 would be a library. 140 would be severe pain. So sound actually can be used as a weapon. Sound can produce pain just like light can. Too bright of a light can produce pain. Too loud of a noise can produce pain as well. And 140 is kind of our threshold of severe pain when it comes to hearing. Pitch is the other part of hearing, and pitch is based on the frequency. So how fast things are coming to you, the wavelengths. The higher the frequency, the higher the note or the sound would be on a scale, and the lower the frequency of waves, the lower the sound would be. And the classic example of pitch is something called the Doppler effect. And so if you stand in one position, they always use the example of a train. So if a train is coming towards you and it's blowing its whistle, you hear the pitch as higher than when it goes past you. And it's not because the whistle has changed in terms of pitch itself, it's consistent, but what's changing is the frequency of those wavelengths coming at you. And that's why you hear that kind of noise going by when the train passes. A couple other senses that are pretty critical for us: smell and taste. Smell and taste are a little bit different than sight and sound. Sight and sound, we've been dealing with something called physical stimuli. So we had either light or we had sound waves. But with smell and taste, we've got, these are chemical stimuli. So there's some sort of a chemical experience happening here. With smell, we have receptors in our nose, and just like with the other senses, those receptors will send data to the brain, and we will be able to smell a beautiful flower or a boy's locker room and differentiate between the two of those things, one being pleasant and one being not so, based on what our brain understands as those smells. Taste, similar kind of thing. Taste is a chemical sensation, and taste is a combination of several different flavors: sour, salty, sweet, and bitter, and those make up flavor. And so this picture here on the right is supposed to look kind of sort of like your tongue. And the tongue is broken up, with the front being the pointy part at the bottom of the picture and the flatter part being the back of your tongue, and that's where those different receptors are. So we have the sour, salty, sweet, and bitter being tasted by different types of taste buds on your tongue. Texture and temperature also impact our taste. So if we have something that's a little crunchier or a little smooth, that can actually impact taste. So those are important too. Those would be physical impacts or stimuli that are also affecting this larger chemical thing called taste. Touch would be the last of our 5 major senses. And in the skin, we have receptors, just like with the other sense. This is a physical type of stimuli again. And we can feel the following things with our skin. We can feel pressure of something pushing down on us, the warmth, the coldness, and the pain of something. And so pain is actually a really good warning signal for us. So when we have too much of any of those things, too much pressure, too much warmth, too much coldness, or too much, well, obviously pain is pain. But we have too much of those things happening, then we're going to have pain. And this is a defense mechanism. So we can get out of there or change our situation, our environment, so that we're not hurt in a large way. Perception. So those are all sensations. Those are all the ways we sense things. Let's talk a little bit about perception. And the perception is, as I said before, the brain attempting to make sense of what's going on in the world around it. So the things that you're seeing, the brain is continually bringing all that in through all the senses. And I say seeing, I shouldn't. The things that you're sensing, the brain is trying to explain as it kind of decodes that. And it does it through a process that's known by a German word called Gestalt. And Gestalt means that there's lots of little tiny bits of information that the brain is receiving, and it's trying to put that together into a meaningful whole picture of something. So, let's say you're standing in the middle of Times Square in New York City, and you've got all kinds of sensations. You've got the sensation of lots of different lights happening from all the different signs. You've got all kinds of noises from the people and the cars. You've got all kinds of impacts from maybe people brushing against you. You've got smells of the different vendors that are around there cooking things up. All these kind of things are going on. These are all bits of information that your brain is trying to pull all together into one experience and understanding it. And it does it by essentially some different mental processes that are listed here. So we have proximity, we have continuity, similarity, simplicity, and closure. And these are all principles of organization. It's organizing this information into a number of different ways. And you'll read more about that in your book here, this particular chapter. We're going to finish off by a couple of things that we'll study, well, at least one thing that we'll study more in depth in your case study this week. And that is illusions, and then we're going to add something called ESP onto that too. Illusions are a lot of fun, and illusions are when our brain is working really hard to figure stuff out and develop these perceptions based on all this stimulation and sensory input that it's getting, and it just screws up. It just can't quite figure it out. Something is out of place. It doesn't make sense to your brain. And here's a classical picture on the right-hand side for you. If you ever go to the town of Pisa in Italy, you'll have to go, of course, to its most famous landmark, which is called the Leaning Tower of Pisa. And it's almost an obligatory picture, a required picture, is you must stand and have your friend take a picture that looks like you're holding up the Leaning Tower of Pisa. So here's this woman who we know is not larger or as large as the Leaning Tower of Pisa. We know that her hand is not on that thing and holding it up, but when you look at this picture, it sure looks like that. So to our brain, without knowing anything about this, we would say this is either a very large woman or a very small building, and it does look like she's doing something here. This is all an illusion, and there's all kinds of different illusions. Some are visual illusions, some are different senses are being screwed up with as well. But that's what happens when we have an illusion. It's a perceptual cue are distorted so that the brain cannot interpret correctly. And the perceptual cue here is that the woman and the building are in the same place, when we know the woman is in the foreground and the building is in the very, very far background. Okay? So those are illusions. We'll look a lot more at illusions, and I think they're a lot of fun. ESP, or extrasensory perception, is kind of a pseudoscience, something that some people believe in. Some people have attempted to try to figure out. There's very, very little information that suggests that it's a real thing, but it continues to pop up. And ESP is essentially where we have a situation where the world is receiving information through channels other than normal senses. So we are receiving information that is not sensory. It's extrasensory. It's outside of our senses, okay? And there's there's four main types of ESP. One is clairvoyance, and that's the concept where we would be perceiving objects without sensory input. So someone who is clairvoyant might say, well, I can speak to the dead. I'm speaking to ghosts. I can sense ghosts. Well, we don't have any information that suggests that there are ghosts there, but you say that you can talk to them. So that would be clairvoyance. A second type would be telepathy. Telepathy is the concept of reading someone else's mind without actually speaking to them, or maybe transferring your thoughts to their mind. So if I stand, on another end of a building from you and I say, ooh, I can tell exactly what you're thinking, I could potentially say that I'm telepathic. A third one is called psychokinesis. Psychokinesis is the concept where you can move objects through mental effort, so that I could actually think about taking a textbook and moving it from one desk to another, and it would occur. And then finally, we have something called precognition. And precognition is the concept of people have the ability to foretell events or see into the future. And of course, if you can see into the future, you can do very, very well in this particular state and this particular city, because you could be a tremendous sports gambler if you knew who was going to win between the Oregon Ducks or somebody else. Of course, we know the answer for that is the Oregon Ducks, because they're the greatest team ever. But in general, most of these things are thought to be non-scientific and not something that we can ever test for, or that people can have at a level where we see some consistency. So that's some information on sensory and perception. I hope you've enjoyed it. I think it's a fascinating study. We'll have some stuff we look at. Like I said, we'll have a chapter. You'll have your normal reading and questions. We're also going to have a case study dealing with illusions this week. So take a look at those, and we'll talk to you soon.